Hi, and welcome to your consolidation session. So this session is a chance for us to just go back over everything that we've already learnt before we add any more new learning into the course. I'm going to literally chuck things at you and you're going to have a go. If you need to look things up, please do. Remember, we're not doing a test here. We are building our skills. We're increasing our confidence. We're wanting to improve and make progress with the methods that we've seen. That's our goal here, okay? Do not worry if you are still making mistakes. That's perfectly normal. What's more important right now is you're just having a go. You're attempting every single question and you are doing your best. No one can ask for any more than that. Okay, so let's crack straight on with this. We're going to start off by factorizing. So I want you to factorize 49y squared minus 63y. So you'll hit pause and you'll press play when you're ready. Okay, so something that I want you to do throughout this entire session is every time you get a new question, I want you to question it, okay? I want you to naturally go through a process of what am I looking at? What do I know? And how can I use it? So if I'm at the what am I looking at stage, I'm looking at the word factorize. That tells me that I'm going to be putting it back into brackets. So that's what that word means to me. I'm looking at a quadratic. I can see there's no equal, so I'm not doing any solving. I'm literally just factorizing. I've got two terms, which tells me it's one bracket. Now I look for what's common. 49 and 63 are both in the 7 times table. So 7 is coming out. And y is in both terms as well, so y will come out. Now, basically, what's going to happen is we're going to divide this into these terms. That's because 7y is a factor of these. Okay, but sometimes it's easier to think of it as a multiplication, which is what we're going to do. So we're going to say 7 times something, a missing number here would give me 49. 7 times 7 is 49. And then y times y will get me the y squared. 7 times something will give me 63. That's 9. And I want to make that minus 9. And I need to be careful that y, I only want 1, is already here on the outside. So I don't want to be putting it in again there. So that's it, done. So that's the answer to the first question. Okay. Now we're going to expand. Oops, if I can write expand. X plus 3, x minus 2, and x minus 4. So pause and press play when you're ready. Okay, I'm going to do these two first. You could do any two you want, really, but it's much of a muchness, isn't it, when they're very similar. So no need to change anything around there. So I'm going to do x times x is x squared. And then I've got minus 2x plus 3x. And then 3 times minus 2 is minus 6. Be very careful with that negative. That could be where you might go wrong if you do. Minus 2 plus 3 is a positive x. And then I've got my minus 6. So all of that now needs to be multiplied by x minus 4. So x times x squared is x cubed. X times x is x squared, and then we've got minus 6x on the end, minus 4x squared, put that here, and then minus 4x, and then minus 4 times minus 6 is going to give me a positive 24, and then that's going to give me x cubed. I've got x squared, I take 4 away, I'm at minus 3x squared, minus 6 minus 4 is minus 10x plus 24, and that is your final answer on that one. Okay, I hope that went well. Most people quite enjoy the expanding of triple brackets, so hopefully you do too. Okay, we've got this one to do next. We're going to solve x squared plus 16x plus 63 equals 0. So hit play when you're ready. Okay, so I'm looking at a quadratic with 3 terms. I know it's an equation. It already equals 0, so I don't have to worry about that. 3 terms are going to be 2 brackets. Drop the x, it's pos, so keep that the same. 63, 7 and 9 make 63. They're both positive, so I can just chuck them in. Doesn't matter if you did them the other way round. We're solving this, so I've got to get each bracket to equal 0. So the x in here will need to be -7, and the x in here will be -9. And that is the answer to that question. So hopefully that went well. Nice little simple factorization there. Okay, next one. I would like you to sketch the graph of x squared minus 36. X squared minus 36. Actually, do you know what? I'm going to write this in a slightly different way, because in the exam, if they want you to sketch a graph, they are going to express it like this. They're going to say, sketch the graph y equals x squared minus 36, which looks very different, doesn't it? So it's probably important that we start introducing that as early as possible. So we're going to sketch the graph of y equals x squared minus 36. Hit pause and press play when you're ready. Okay, so to sketch the graph, let's get my axes set up and ready to go. So to sketch the graph, I am going to need some coordinates. I'm not going to draw a table and try and do anything accurately because it says sketch. What I'm actually going to do is I'm going to factorize this bit here, and then that will tell me where it crosses the x-axis. The solutions to this are the roots of the graph, and the roots of the graph are on the x-axis, okay? So I'm looking at that, I'm seeing 2 terms, so I'm going to automatically do my 1 bracket. But then when I look at the terms, x isn't shared in both, there isn't a number in both, so actually this is the exception to the rule. So this is where I'm going to put on a 2nd bracket, check that's a square number, which it is, so it's all fitting with that exception of the rule. X goes down, and then square root of 36 is 6, so it's +6 minus 6. So the solutions are the opposite, x equals -6, x equals 6. And then my graph is going to cross with that symmetry. -36 is the where it crosses the y-axis. So if I'm going to do this by hand, that point there is -36, or you could call it the coordinate 0, -36, and then these points are our roots, -6 and 6. Okay, so hopefully that went well. I'm throwing a lot at you. I'm making you remember a lot of detail here. Quadratics are a massive part of the higher GCSE. So the more confident we can be with our quadratics, the better, because everything seems to build on a quadratic. If I want to make something harder, then I'll create a quadratic, like appear in the workings out. So quadratics, we really want to spend the time here because they are going to make a massive difference and elevate your grades. All right, let's do a different question. So I have one that I wrote out because this is slightly different. I really want you to not be afraid of, there we go, let's squeeze it in there. I really want you to not be afraid of things that you haven't seen before. I want you to build the confidence, and it is a skill in itself, to be fair, to look at a question you haven't seen before and really give it a good go. We know no matter how much revision we do, we are going to see questions in our GCSE that we have never seen before. So it's not about trying to find questions we recognize. That's not how we're going to get the best grade. It's being really confident with our knowledge and knowing how to use it. All right. So with this question, I want you to do exactly what I've been demonstrating and suggesting all the way through. I want you to just take some time and look at the information in the question. So what am I looking at? And then once you've taken all the pieces that you've been looking at, think, well, what do I know about these things? And then how can you use that knowledge? What do I know? How can I use it? And just see how far you can get. Don't worry if you get lost a little bit, because it is new and we're at the early stages of applying our knowledge. But I've got to do it to you, I'm afraid. Otherwise, I am not going to help you make those steps. Okay. Press play when you are ready to see what's happening here. Okay, so I am told that the area of this shape is 36 centimeters squared. Okay, so I'm looking at the shape and I can see it's a square. I know it's a square because of these 4 lines. That means that all the edges are equal. So if the base is x plus 2, then the side here, all the sides are going to be x plus 2. So that's one of the first things that I can mark down on that. I know the area of a rectangle or a square, okay, is base times height. So that's not going to change in this. The only difference is I don't have the base and the height as an actual number. I have the base and the height as a piece of algebra. Okay, so I am going to have to use that. So I've got the base of x plus 2, and that is being multiplied. So all of that, I put it into brackets, is going to be multiplied by x plus 2. Okay, now remember, a piece of algebra is a number. It's just a number I don't know yet. Okay, so I can crab's claw this out, which would give me x squared plus 4x plus 4, once I did all the tidying. And what I now have is this piece of algebra equaling the area of the square. Okay, but I also have in the story a fact about the area of the square. I know it equals 36 centimeters. That means that this expression, this piece of algebra, is equal to 36 because they are both representing the area of the square. Now I've got a quadratic that I can solve. So looking at it at the moment, what do I know? I know a quadratic has to equal 0 and this one doesn't. So the first thing I'm going to do is pick up my 36, get rid of it to the other side. It'll land as minus 36, which will give me x squared plus 4x minus 32 equaling 0. I can now go on and solve this. So 32 is going to be 8 and 4. So I've got x, pos neg. I want to make a positive 4, which is going to give me 8 and 4 here. So x is equal to minus 8 and x is equal to 4. Now, an edge of a shape cannot be negative. Okay, if I took my minus 8, so I'll just highlight that. If I took my minus 8 and put it up here as minus 8 for the x and added 2, I would get minus 6. There is no way an edge can be a negative number. So there's no way that the x equaling minus 8 can be a solution to this question. So it's not. I ignore it. The solution to this question is x equals 4. If I've got 4 and I add 2 to that, I get positive 6. The area of the shape, base times height, 6 times 6 is 36, which is what I want it to equal. So work out x equals 4. Now, you may not have done all that because you may have been able to think, okay, if the square is 36, then the edges have got to be the same. And 6 times 6 is 36. And 6 take 2 is 4. So 4 is my answer. You won't get a question that's that simple in the higher exam. So it's really important that we use simple questions where the numbers are easy for us to follow whilst we're learning how to apply our methods. So yes, you may very well have seen that and then did that, but you would not be getting any marks because you're not showing the algebra that we would use in order to get to that result. And as I say, the likelihood of you having a question that's seeable, that you can just process, is incredibly unlikely. So these steps are really, really important. Okay, so that is of that question. I have written us another one actually, which I will go and get down and bring up. Just thought this would save a little bit of time. How much? We'll go up to there. That's far enough, isn't it? When you need to see it all. Ooh, jumping it around. There we go. So we've got funfair tickets for 2 adults and 3 children costing £54. Funfair tickets for 2 adults and 5 children cost £70. And your job is to work out how much an adult ticket costs. All right. So pause and hit play when you are ready. Okay, so this one's fairly easy for us to identify as the simultaneous equation question, just simply by the fact that our learning has only had one area of really wordy questions, and they link to our simultaneous equations. But obviously in the exam, we're going to have loads of wordy questions, and we're going to need to be able to pick out the fact that this is a simultaneous equation. So when I'm reading this, I've got funfair tickets for 2 adults and 3 children. I've got 2 different types of things going to that one value. Okay, so that's the type of thing that I'm looking for. I am going to write that in shorthand. 2 adults plus 3 children together will make 54. And you can kind of see it when we write it in mathematical notation. Okay, when it's written as a sentence, it feels difficult to understand. But as soon as we write it in our notation, where we write things kind of in code as simply as we can, it becomes very easy to read. 2a plus 3c together is 54. And 2 adults plus 5 children is 70. Fortunately, the first term is already the same, so I can go straight into my takeaway. Take, circle, always do that. The 2 A's have gone. 3C, take 5C is minus 2C. And 54, take 70 is minus 16. I'm then going to divide through by the minus 2 to get me C equals 8. So the children's ticket costs £8, but they don't want me to find that. They want me to find the adult. So I've got to keep going. So I'm going to choose the top one, 2a plus 3c equals 54. I know that c is 8. So 8 is now going to go where that c is. So I've got 2a plus 3 times 8 is 24, equaling 54. I'm going to go on and solve this now. Okay, so that was plus, so it'll be take on that side, 2a equals 30, divide through, and a equals 15. How much does an adult ticket cost? £15. Okay, so really, really well done if you got that right. Okay, let's do some more questions. So we're going to solve 3x squared minus 22x plus 24 equaling 0. Oh, just squeezed it on. Okay, so I want you to hit pause, have a go, and hit play when you're ready. Let's get me out of the way a little bit. There we go. Okay, so I'm doing my usual check-in. Okay, it's equaling 0. It's a quadratic. Everything's set up the way I want it to. We've got the 3 terms. So we're going to have 2 brackets. Drop in the 3x. Drop in the 3x. It's neg pos, so it will be neg. 3 times 24 is 72. Now I need to think about whether or not there's a combination that will give me 22. That's what I'm looking for. If there isn't, then I could use the quadratic formula. There is. It is 18 and 4. that's what it is, 18 and 4, which I can just throw in because they're both negative, so I don't need to think about the signs, okay? I'm now going to divide this one by 3 because I want to simplify this down. So that's going to give me x minus 6. Can't do anything with the other one. So that's my equivalent equation. Going to do my check. X times 3x is 3x squared. Minus 6 times minus 4 is 24. So everything's looking good. So my solutions are x equals 6 and x equals opposite sign again. So it will be 4 with the 3 coming in underneath. And that is the solution. Now you could use the quadratic formula. It doesn't say solve by factorizing. So if it doesn't tell you how they want you to do it, you can do it whichever way you like. So if you did get to those results using the quadratic formula, you've done a perfectly good job. You've just did it a different way and chosen a different method. That's it. All right. I would generally factorize if I could, because if it factorizes, it's usually just working with my times tables, which is a bit easier than faffing around with the formula, especially with the negatives and things that could go wrong whilst I use that. So that's why I would opt for my factorizing over my quadratic. All right, let's do another question. We're going to expand x plus 2 squared x minus 5. Okay, hit pause and press play when you're ready. Okay, so I hope nobody did this. X to the power of 2 is x squared, and 2 to the power of 2 is 4, and then times that with that, because that would be wrong. Okay, remember, really important, that the x plus 2 squared means x plus 2 times x plus 2. They are highly likely to do this to you. They are trying to catch you out. You've got to not let them, okay? So this is going to give me x squared plus 4x plus 4 once I've expanded and tidied up. I'm going to multiply that through by x minus 5. So x times x squared is x cubed. I'm going to keep going like that. I've then got plus 4x squared plus 4x. I'm now going to do the minus 5 with everything and obviously carry on through. So that is minus 5x squared. Minus 5 times 4 is minus 20x. Minus 5 times 4 is minus 20. So let's add the cubes together, the squares. We've got 4x squared and then minus 5. So that's going to give me minus x squared. 4 minus 20 is minus 16x minus 20. And that is our final answer. So if you got that right, fab. Absolutely brilliant. Well done. All right, then. We have another pre-written question. So let's go down and get it. There it is, right at the bottom, just saving us a little bit of time. So let me just bring it up. Probably as far as nearly up to the top. Might as well go all the way to the top now. We're there. There we go. Okay, I might even resize that a little bit. There we go. So Andy paid £12 for 4 teas and 4 coffees. 3 coffees cost as much as 2 teas. How much do 5 coffees and 5 teas cost? So this one is a little bit harder. You've got to really think about the information that they're giving you and how that will look like as a piece of algebra. All right, give it 100% and come back to me when you're ready to check in. Okay, so the first bit's really, really easy. It's 4 teas and 4 coffees that cost £12. So I'm literally going to 4 teas plus 4 coffees equals £12, and it's job done. Really, really simple. The next line says that 3 coffees cost as much as 2 teas. That means they cost the same. They are equal to each other. So as a piece of algebra, that would look like this. 3 coffees equals 2 teas. Yep, done that right. Okay. Now, if I bring this across, this kind of doesn't really work, does it? I need all the T's and the C's on the same side. So I'm going to have to rearrange this. So I'm going to take it back over there and I'm going to rearrange this so that I've got everything on the right side. So that's going to move across. It's going to land as minus 2t. Okay. And if I put these now in this position, minus 2t plus 3c, it's going to equal 0 because obviously I've got nothing left on that side. That to me is not really what I want. I don't want a negative at the front here. I will avoid that at all costs because it's just going to interfere with my method in the way that I've learned to use it. So I'm now going to decide that the sensible thing here is to just switch the coffees and the teas around. So instead of starting with the teas, I'm going to start with the coffees. So I've got 4 coffees plus 4 teas equaling 12. I've got 3 coffees minus 2 teas equaling nothing. And that way I can just go now in my normal way of doing my simultaneous equations. Okay, you may very well have started with the C's at the beginning anyway, because we're just problem solving. So we're doing it in the way that we see it, aren't we? Okay, so we've got to take away. Hang on a minute. If I go straight into take away, that's not going to work out because these aren't the same. So before I can do that, I'm going to have to get those the same. So I'm going to multiply this by 3 and this by 4. So that's going to give me, let's see, what's that going to give me? That's going to give me 12c plus 12t equaling 36. And it's going to give me, obviously, 12c, because that's what we want, minus 8t equaling 0, because anything multiplied by 0 is 0. Now I can do my taking away. Take, take, and circle. Okay. So 12c, take 12c. The c's have gone. Fabulous. I've got 12 t's. This is a minus and minus. So I'm adding, okay. 12t plus 8t is 20t. And 36 take nothing is 36. So divide through by the 20. Please make sure you are using your calculator where you need to. That is going to give me 1.8, which is technically £1.80 for my cup of tea. So now I can go and use one of these equations. I'm going to use the top one. You may have used the other one, doesn't matter. Okay, I've got the price of tea. So 4 times 1.8 is 7.2. And then I'm going to obviously get that 4c on its own by hopping the 7.2 over. Going to land as a take, giving me 4c equal to 4.8. Divide through by the 4, and c is 1.2 or £1.20. Okay, let's just collect all this up. Just make it a little bit smaller, because we haven't quite finished. It's not about what a cup of coffee or a cup of tea costs. We actually want to know what 5 coffees and 5 teas cost. So 5 coffees would be 5 times 1.2. I want to add 5 teas, which is 5 times 1.8. And that would give me 15. So the final answer is £15. Okay, so hopefully that went well. They will be looking for simultaneous equations. They students that get stuck and don't know it's simultaneous equations will do like a trial and error. They'll try a combination and they'll keep improving that until they find the right answer. And I love that, because it shows that they're not giving up. They're really putting a lot of effort into finding those answers, but they won't give any method marks. All right. They'll see that you've worked hard to get the answers and they will give you the marks. for just the answers. You might get 1 mark, but you won't get anything else. And even then it's a risk. So they really are looking for you to be using simultaneous equations when they're hidden into these worded questions. All right, so we've just got a couple more and then we'll be finished. So if you're starting to get tired, if you can hang on in there for these last 2, great. If you've taken a break already and you want to take another, do it. You know, it's your session, so you do what you want. Okay, I am going to give you x minus 3, x minus 1, and watch this, x plus k. Okay, I'm going to tell you that when this is expanded, it equals x cubed minus 2x squared minus 5x plus 6. And actually, you've got to try and work out the value of k. All right, now we have talked about this in a session, but we certainly haven't seen this in this type of question before. So this could leave you a little bit like, oh, I don't know. Feel free to just listen on if you really don't want to have a go. Otherwise, just hit pause and play around with the question, see what you can come up with. Okay. Okay. I could start doing a lot of expanding so that I could start to see these different terms coming together, and that might help me work out what I need in order to finish this off and make it work. But I don't need to actually put that much work in at all, because these numbers on the end, when they multiply together, they make the single value at the end of the cubic. Okay, now we did mention this in a session, but like I say, the chances of you remembering it is going to have been really slim unless you made a note of it, of course. So what I've actually got here is minus 3 times minus 1 times a number I don't know equals 6. Well, this bit here, minus 3 times minus 3 is 3. 3 times a number I don't know equals 6. K has to be 2. And it is that straightforward. But if you don't know, it's really hard. If you did it the long way and expanded everything out and managed to find that k needed to be 2, then you did an awesome job, because you must have put a lot of work into that. It will work doing it that way, but you just don't need to. So that little fact is a bit of a gem. It's really worth knowing. Okay, last question. We are going to solve 2x squared minus x minus 4 equals x plus 4. And you need to give your answer. So give your answer to 2 decimal places. Okay, so let's just bring that down. Give your answer to 2 decimal places. So hit pause and press play when you're ready. Okay, so I'm being asked to solve a quadratic and it does not equal 0. So straight away, I am saying no. I have to sort that out before I even worry about what method I'm going to use. So the x and the 4 have got to go to the other side. So the x will land as minus x and the 4 will land as minus 4. So that is going to give me 2x squared minus 2x minus 8 equaling 0. So that is the quadratic I have to solve. So I'm going to look at my factorizing. Always check that first. So I am going to do 2 times 8, which is 16. I need to find a pair that's going to make me 2. Okay, so 1 and 16 isn't going to do it. 2 and 8 isn't going to do it. 4 and 4 isn't going to do it. I might as well stop. This is not going to factorize. I am now back into my quadratic formula. To be honest, I should already know that. So I run through my checks, but I needn't have bothered with all of that. And this is why. Over here, it has said, give your answer to 2 decimal places. That is your kind of massive hint. It's not going to factorize. We don't factorize to 2 decimal places. We factorize with integers. So that there tells me straight away, don't bother. There is no way that factorizing is going to work. So that is another thing to watch out for. But I'm just following the process in case you did it that way. So we have got our formula, minus b plus minus square root of b squared minus 4ac all over 2a. I'm hoping that this formula is now coming more naturally and we're remembering it. We must have written it out a lot of times now. If you haven't been writing it out every time you've needed it, make sure that you do, because it's the best way to get it to stick. Okay, so what have I got? I've got A equals 2, B equals minus 2, C equals minus 8. So I've got some negatives in this. I need to be really, really careful. So I've got minus B, which is minus 2, plus or minus, okay, B is minus 2, which I must remember to be careful of in the calculator, minus 4 times 2 times minus 8. That is all over 2 times 2. A really common place for an error to happen is here as well. Quite often, because this is -2, we forget to put the negative of the formula down, and we end up not getting the double there, which is obviously really important. We need that. Okay, so we're going to do the norm, tidy these 2 bits up. So I'm going to have, and obviously, actually, we've got to tidy that as well, haven't we? So I've got 2 plus minus square root of 68 all over 4. Okay, so let's keep going. This is going to split into 2 plus root 68 over 4 and 2 minus root 68 over 4. So x is going to equal 2.56 to 2 decimal places, and x is going to equal minus 1.56 to 2 decimal places. So we've done quite a lot of work to get to that final answer. And hopefully it went well. Right, guys, that is it. Okay, not going to do any more than that. It gave us a really good opportunity to go back through all those methods that we've learnt. We are moving on into a completely different piece of learning. So we're leaving the algebra behind in a sense that we're not building on it anymore. We are going to see it at the beginning of every session as part of our recap, because we don't want to lose these skills. We want to keep reminding ourselves so that that recall eventually comes really naturally. We start being really fluid with our methods because we have them much more secure. So you will see this at the beginning of every session, but we are moving into something completely new. Okay, so I'm looking forward to doing that with you. Well done today. That is a tough old session, very intense.